Welcome to Renaissance Charge Videos. I'm Rick Friedrich, and this is another instructional video for my 4-Dualpole Mini Kit. And we're going to go over not only the procedure on how to make it, but also a new option, which is what I've been showing in my motors in the last 2 years, starting with the 30 coiler, where we ran both triggering ways at the same time with different coils. So in this video we're going to put together the kit normally, but we're going to change one of the coils to be a bifilar coil instead of just a regular one-wire coil, so that we can use that to trigger itself, where the other three will run as normal with the MOSFET and the Hall triggering, the Hall switch, which is a positive triggering, and the other one's a negative. So the first thing I want to make a distinction on is when you buy this kit, you will have two options, and I think I'll probably add the third option to give you extra parts that will be over here. I'll show this in the video in time to do the optional dual system. But I will provide from now on the kit with the bifilar coil so that you can use it either way. Because what I want to do is, in the future, I want to provide for you the third stage process, which you can multiply this energy out again and again and again, and you need the trigger coil for that. So I don't want people to have to try and take it apart and replace this coil when they could just have it there from the start. So this marks this last year in a bit marks a turning point back to the negative energy switching, but we want to still retain that positive switching and running, because it has its advantages for motor use, for self-starting, and more of a regulated run. So a combination of the two is actually where I've been moving towards in the last year or so. So we can go over that later when we add that part to it. For now, let's go over a few things. This video is not going to cover everything that those who buy the kits will have. Like, I'm not going to show you all my schematics and all that, because that's what comes with the kit. Now you'll be able to understand more or less how we do this, and I will show you the optional schematics with the trigger coil and that, but I'm not going to post everything. I'm not going to give away everything, including my bank account. People want everything. I give away a lot of things. I do open source all this stuff, but I'm not going to do everything like that. So now, the first thing I want to mention is we have a parts list that comes, over 200 parts come with this kit, and a lot of it's already prepped. The coils are already wound, the magnets are pressed in the rotors, the set screws are already in there, they just need to be tightened on the shaft. And I have the circuit board stuff, 2 circuit boards here. So it eliminates a lot of the mistakes I found that people will make by putting the parts together like that. So really there isn't too much. Now I have already put these wire clips on here for the sake of time, and 7 out of the 8 shrink tubes are on the coils for the sake of time here. Now, the other thing to notice is there's a couple of things that are not included in the unassembled kit. That includes one extra switch with these two white wires, not a big deal, and these clips rather than these basic clips that will come with the unassembled kit. So other than that, it's all exactly the same. The assembled kit allows you to just literally plug it into the batteries. As long as you have the charging batteries on there securely, it's good to go. And it will self-start and so forth. So I will only ship it with the regular way with the Hall switch on all 4 coils unless somebody requests otherwise or I create an option on the order. But I will from now on leave the trigger coils on there on 1 coil so that that could be changed in the future. So you get this sheet and 6 or 7 other pieces of paper, instructions with this kit, a full schematic, and then also the optional schematics which we're going to look at today, a list of videos that I've made pertaining to this kit. I'm doing this video over again because we've made improvements and changes since the last videos, and people get confused if they try and look at the videos that have the reed switch or the board that had 4 transistors on it and so forth. Now we're using a MOSFET, which is a lot easier. And then secondly, well, I'll be making another change to this, so this video won't be up to date. In a few weeks I'll be adding a MOSFET driver to the circuit, and that will come in the instructions, but it will it'll be a different MOSFET and a different driver that one of my customers played around with and showed me a little bit of an advantage over. And the MOSFET driver, I believe, gives you the ability to change the voltage up to 24 volts, or I think we actually will go up to the 36 volts, because the Hall switch can go up to 36 volts. And so you just don't want to put 24 or 36 volts across the gate of the MOSFET, so you need the driver to do that. And the driver will allow for better control, more efficient control, less losses and so forth. So that's the parts kit, or the parts list. So now what we're going to do is start off, we'll just move all these wires over here for now out of the way. And we'll go over one part at a time so that you know. Now, the first thing to note is don't put these together, these magnets, because it'll be hard to take it apart. You'd have to twist it to get them apart, and it's very hard. Now, these are pressed in, but you'll notice that they're opposite to each other. So there's the magnets. The side that has the lines in it is the North Pole, so that makes it easy now. And the other side is the South Pole. So what we want to do is point the North Pole up. So in this case, this will be the bottom rotor because the lines are on this side, and this will be facing upwards. And then this one with the lines on the top will be facing up. This is for the northern hemisphere. If it's not very, it doesn't really make a difference, to tell you honestly. It's just the magnetic streams point more in that direction, so that's the way we've done it. No big deal. If you want to reverse it, all you have to do literally is flip it over, and then just rearrange these bolts and feet around and move the shaft. No big deal. So what we want to do starting off is put the rubber feet together and pull them through, and then we will put the nuts and bolts on here. I'll probably do one of these and then we can speed up the camera so that you don't have to wait around for this. Now this is a 9mm nut. So you just want to do it snug so that it doesn't become loose. Probably a little bit tighter than that. You'll see it kind of starting to bulge. And then you just want to do them all the same. And then what I do, and you can choose your own gap size. I take a nut on the flats and I put it down so that I can have an equal space on all of them. And then we'll put that on the plate. Now this is important here. What we're going to do here is I point these holes towards me. These were the holes that we used to use for the timing plate when we were doing the reed switch. And they can still be, they'll still be used for holding down the Hall sensor, but I've made my gap smaller between the rotors and the plates, so there really isn't too much room for a timing plate there anymore. It's just added expense. So I just stopped making that. And then, but you could use a thin timing plate if you wanted to move it around on your own. I don't have one anymore. So now this is important that you put the bearing, there's two sides to the bearing, and I'll come up to the camera there to show this. So if you look carefully, there's the side, the bottom side or the outer side will be where the bearing is pushed into the plate, and that will be the top side, because essentially we're pressing the rotor against the side of the bearing through the spacer. So what I'll do is make sure I start off by putting the feet in there, or this in there on the right side, because otherwise it won't work. You won't be able to hold the rotor in if it's the reverse way around, and the bearing will come out eventually if you do that. So what we want to do is put each one of these down one at a time. Now, the other difference that I do with this kit, when I assemble it, is I put this original Bishop's oil or Slick 50, the original Slick 50 formula, not the present one. And I'll put that in the bearings in a moment. And that gives you the ability to have much better, less friction and longevity for those bearings. It makes a massive difference. Now these are cheap bearings. The good ceramic bearings are like $5 a piece or something. And I sometimes use them, but I don't provide them in this kit. It's pretty expensive. one thing I was going to mention was, just the other day, I did a video on the Bonita system, and I showed these batteries. I mentioned later on that these batteries were more fully charged. So after several days, you could see they're at 25.4. You can see that. Anyway, that's not to say if you believe that I'm not a liar, then you could trust that testimony, but the fact is that those batteries ran that load for 20 minutes and then were more charged than when I started. So it actually is interesting because I can find that the charging batteries can come back to their state too that they started, but then the input batteries charge up more. So that's 1/10 of a volt, that's not 1/100th of a volt, because it's on the 24 volt setting. So we can do the same thing with this kit, but it's harder on the transistor when you do that, so it's more risky. And that's one of the reasons why I say the third stage process is more experimental right now, and I don't give out the exact details on that, on what I'm doing, because it's still in development, and you will blow out your transistors or damage them and not know it. That's the thing that I just wrote a note to on my YouTube channel in a question that was asked, and I said that the transistors can go negative, and you can see that on an oscilloscope just when you just use one terminal across the on the collector while you're running the motor. You can see it go negative, but when you damage the transistor and it still switches, you can end up seeing it not go negative, and that will make a big difference. Oops, see, I almost did that wrong. Make a big difference in your performance output. And I've seen that. There's a guy who bought a kit from me, assembled. It was one of my large 4-poles, and I actually did the last video that I did on that. Well, video that I did this summer, I believe it was. And then I sent it to him, and then he ended up using only one battery and ended up ruining and melting down coils and what have you. And he replaced the transistors that were clearly blown, but I believe that he still has damaged his transistors so that they're not giving him the results in the charging that I had, at least. And so you can still damage your transistors without completely destroying them. And that's something that few people realize. So if you're going to do this third stage process, which essentially I've actually shown you everything that's in the box. If you look carefully at my videos, I did show you what's in the box. And I'm not trying to be sneaky or give you hints or whatever so much as I actually told you. Because what I'm trying to do is teach you how it works, not just following parts and saying, okay. Because as soon as you start doing that, if I tell you something like that and you don't know the basic processes here, the beginning stages, then what's going to happen is you're going to be dependent upon somebody always to tell you how this works and what's going on, and you won't understand why things work or don't work. That's why I'm making these comments right now. So now you can see this is square because of the spacing. If you don't measure that gap there, you're going to have this unbalanced. So I put extra nuts on there because I'm going to put the top plate on. And again, the bearing is going to become pressed down on here, and then I put the holes on the same location for whatever reason. I just remember to keep them in front of me. So we're going to put this last coil together. Now this one is a bifilar coil. So you hold down the wire so it doesn't unwind. In this case there's two. And now only the inner one is going to stay down. And we're going to put the heat shrink tube through, or the wires through the heat shrink tube. Put it over top, and then just make sure it doesn't unwind on you. I usually keep the wires in the same direction. This is a pretty big heat shrink tube. It's a little big for it, but my guy sent me the wrong size, and I got a lot of it, so I'm stuck with it. Anyway, it shrinks down to the right size. You don't need it. I just like things neat and organized. I mean, you can make it so that you don't have it. If once in a while I forget to put it in the kit, it's not a big deal. It is an optional thing. All you gotta do is make sure the wires are tight anyway together. So the first thing is to note the upside down, or the direction of the coils. So what I'm going to do is put this motor coil off to the side here. Oh, that's one thing I don't have is the rods. But we'll put the rods in after. So what I'm going to do, just for the sake of these bases, I'm just going to put them in opposite direction. So I'm going to put the motor coil, or the generator coil, which aren't always this color. I'm not sure what the next color will be. It just depends on what they send me. But this is good motor wire. This has got what's called double insulation, or heavy. Anyway, I put the generator coils facing up and the motor coils facing down, and that will be important as we pick the wires. As we pick either side of the wires to make sure they're all the same. So we just align them up like this. And then I just put I've done many of these, so I put the wires in a certain order. And then I just make sure that specifically the last coil doesn't rub against the shaft. So this one right here, I just want to make sure that the wires aren't going to ever rub against the shaft. So, you just line it up fairly close to where the holes are going to be, and then you make sure, double check, that the bearings press down from the outer sides of both these. Then I line up these holes. It's important that that plate is lined up in front of you where all the wires are coming out, because we're going to put the Hall switch there. So now we've got 4 more nuts, and we're going to just hand tighten these down. So you just want to squeeze it a little bit, not too hard. And then you don't want to tighten the bottom ones until we're done moving these coils around. to put the rods in. Now these spools were made a little bit smaller than the original ones. They were actually made in Germany. You can blame us Germans for the mistake. They're a little bit smaller, so the rods are quite tight, but that actually works out better because it holds them in more. Now, before I forget, I'm going to put this in here. Alright, I got some rods here. So what we're going to do is take about 8 of them or so and put them in, and then add 1 or 2 more. I think there's 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now what I do is I don't put it all the way down because it's quite a racket to vibrate everything on the table. I wait till I've got them all ready to hammer. I just tap it a little bit and move on to the next one. If I try and do them all one at a time, then I could move around the coils too much. So what we're going to do is turn on our glue gun. I did bring a glue gun out here, because it takes a while for the glue gun to warm up. And we're going to use that glue gun twice in this setup. The other time we're going to use it is with the Hall sensor. When we place the Hall sensor, and when we have the spot where we want it, we solidify it with the glue, and that way if you ever want to move it again, it comes off easy. And if you want to create 2 possible ways to rotate the motor, you can have 2 different halls and just switch between them. And that's probably better, although you can switch a plate, because the plate will give you different power levels. The MOSFET can't be easily adjusted without a special driver by changing the voltage. So there's no power level selection on this particular model like we have with the transistor setup. The transistor setup wasn't as efficient as the MOSFET. That's one reason I went to it. Once in a while it's harder to get these in here. So you want to eyeball it and look down. If you don't line those holes up exactly, then it's hard to get the last rod in. Tends to catch on the lip. I've done, I don't know how many of these. I've never counted how many, but quite a few of these. Trying to get other people to help manufacture, and people let me down. So I'm still assembling this particular kit by myself for people who order it assembled. So that's it. Now, doesn't have to be too tight in there because we are going to glue it. So let's, I suppose right now we can actually so what I do is I just give it another squeeze, pull up the bottom nuts, and then tighten it down. Now what you can do is make a bigger space here so that this shaft doesn't stick up as high as it does. I'll get into that in a minute. Alright, so now actually I need to tap these. Now you can put a block of wood right under it, especially the ones in the middle. It tends to bounce. The ones on the corners don't bounce, but these ones in the middle tend to bounce. Anyway, they're not going anywhere, but just in case one of them gets loose. So now's the time to wipe it off before you put the rotor on it. And so now our heat gun is warmed up. It's a little bit of a mess, but it's easy to clean off. So what I do is I dab it on and spread it around. It's kind of a messy thing, but you don't really see it once you've put the rotors on. I found if I don't push it down into it, they tend to just make a little hat and come off easily. When I do it this way, it's really secure. None of these rods are going to come out. If you don't do this right, one of these rods can come up and scratch the rotor, and it will stop it in a real hurry. It's not going to really ruin anything, but you don't want to scratch a rotor if you don't have to. So then you do the bottom ones, take off these little pieces of plastic that come up. And just make sure there's no pieces sticking out like this one. A little bit sticking out. And again, these coils and rotors are absolutely ideal or perfect. There's always improvements we can do on these motors as the motor. But really the motor isn't really the important part of this system. It's really the batteries. So now we want to unplug this before we smell up the whole rim. And now we're done. So now what I want to do, well, might as well do the rotors right now. So I have these spacers that you get. I can't get them the size that I want them. So if you don't cut them, the gap is going to be bigger between the rotor and the coils than it needs to be. So what I do is I take some shears. I've got two of these shears, really big ones, that these ones work better than the other ones, so I guess they're sharper. But I'm cutting this down to a little less than a 1/4 inch. A little bit more than 1/8 of an inch. And then if it doesn't do it just right, if I have a little bit on the side, then what I do is I take a file and file it flat. Just one of these things that I need to find another part for. So these spacers, now the point is that the flange part of the spacer will go up against the rotor, the flat part, and the smaller part goes against the bearing. So remember, the bottom, I'm putting the north poles up, and this is important because if you don't do this correct, and sometimes these are really tight, these last shafts that I got were really tight. I got a bunch of them at my last meeting, and the guys had to file them down in order to get them over the bearing, so it's only happened to me once. So you just want to make this not stick out lower than the feet, of course. So now I'm going to put this piece on the top one, which is a little bit hard. When I've cut it, it kind of bends it a little bit. Hold on, I gotta bend it back. All right, so now north pole facing up. This one, south pole facing down. And so as soon as we put one rotor on, well, they actually naturally fall in front of the poles, the motor poles. So I tighten it by hand this way. Give it another snug. And then this side, it will just sit. I don't have to actually look at these. Like the larger 4-pole and the 10-coiler, we have to line these up specifically with where the opto sensor is placed to get the right timing. So that will be it for the rotor. Now, so you can put a little bit more of the, well, I'm not providing this with kits anymore, except for the assembled ones, because It's just a hassle and a mess. So now I gotta braid the hair here. And so what I'm doing now is taking the wire, the thicker wire, and separating all the generator coil wires out of the way. And then what I'm going to do is look for the top wire on all of these. And don't confuse them, because if you get it wrong, the whole thing, you'll be fighting coils. One of them will be upside down. So then what I do is I just kind of pinch this off. Well, for these ones, I'm not going to do these ones first. I'm going to move those on the top. The bottom ones, in this case, I'm going to twist these. Because I'm going to be doing something different here, I want you to pay attention to this point. One of these top wires, which is this one, I'm not going to twist these wires like I normally do because of the fact that I'm going to be using this wire for the trigger coil. But normally what I do is what I'm going to do on the bottom wires, which is the wires going to the all the top of the coils, or in this case on the bottom, they're upside down from the diagrams, but the outer wire, the wire that you end up with on the outside of the spool, is what is going to go to the primary positive battery, right? So now, since they're all going to be tied together on both circuits, it's no big deal. I am missing a wire here to do my wire stripper. Bring it. So this is great. First, I'm certain that you don't have one of these. If you come to my meetings, you actually get to see this and use it. So you want to adjust these so that they don't take too much off. So I'm going to strip these first. Otherwise, do not use sandpaper maybe, but do not use a lighter, because you're going to damage the copper. It always happens. Oh no, I do it all the time. Well, yeah. Trying to figure out why your results are the way they are. You've damaged your copper. Use an X-Acto knife and scrape it off. That's what I did for years, until I got one of these. So now I'm going to just put it in the drill chuck. And then I just hold the end. Just makes it nice and neat. So we have that. And this one is ready to solder. The other one, like I said, I'm going to what I'm going to do is cut these at the right length. so that they're all the same. And then strip them. So where do you get this red china? Alright, so I've done these, and I'm not going to I'm not going to twist them like I normally do because of a certain reason that we're going to be running these trigger coil. Now these are a slightly smaller wire, actually half the size. They're like 26 gauge wire. Same with these trigger coil wires that I'm doing right now. Usually I do 23 and 26 gauge motor coils, 26. Now with these, what I do is usually I do this actually before I put the rotors on so I can see better. So I find usually the left one and start off with either the top or the bottom generator coil. And I just make sure, usually I do the longer one as the first wire. Now I'm going to make these generator coils in series with each other. So I'm noticing that this wire is the upper one. So what I want to do now is find the other side, which is the lower wire of this coil, because this is going to be, we're going to go around in series, 1, 2, 3, 4, put them all in series with each other, top to bottom, top to bottom. So if this first one was the upper wire, then the last one is going to be the bottom wire. Oh, you know what I did? I did that one wrong. So now I'm in trouble. I'm not about to take this all apart. So what we're going to do is it's just going to be backwards. But just in case it doesn't work out, I'm going to leave these two out of the mix for now until I'm ready to do this. I'm going to put these over here, and I'm going to put the other ones up in series for now. So we go from this one. So the other coils, I'm going to bring them all together. And again, just go like this, pinch it off so they're all guten tight. That's my funny fake German expression. And then snip it, get rid of all this excess wire. And what we're going to do is run these wires in series with each other from top to bottom, from coil to coil. And then what we're going to do is measure that last coil. You see, we don't want to put the coils in backwards from each other because they will cancel each other out. And that's why I'm leaving those extra wires there until I figure this out. So I'll just strip these for now and then figure out later on, because I put the coil in upside down. So now for these ones, I've got these shrink tubes here. I guess I need some more of those. So the bottom one is going to go, the bottom one of the left coil is going to go to the top one, the top end. And now I'll say something about these generator coils. These generator coils were not to produce a ton of output. What they were actually was to show you something. This kit was a learning experience. And you'll be amazed to know what you can finally do in the end with this kit. Literally, this could be a prime mover. In the end, you will see that you can use this kit to power up loads that you could not possibly imagine, as this being the first prime mover, so to speak. But the generator coils were also a learning experience to teach you that when you short out the coils, the motor actually speeds up faster. And then if the motor coils were not even placed in there at all. And then so when you have a load that's very similar to shorting out, it will still do the same thing as I've shown in earlier videos. When we load it down, it'll speed up. Now, I can show you that by shorting out these white wires later on, the AC end of the bypassing the capacitor. And that was to explain something to you, to show you something very unique. But the generator coils will put out some output, but not equal to the input, because there's still a whole lot of torque left on this motor, even with the generator coils running. Because if we actually have that ideal load on the generator coils, or just short it out, the motor will speed up. So we have still a significant amount of torque. So generator coils were not meant to be like a regular alternator. And when you have the pulsar system on them, then they, rather than a direct constant current, you have a better result. So now what we're going to do is add these two wire ties. So essentially, one's going to go up, one's going to go down, feed it through. Avoiding the wires. And what we're going to do is just tighten this down. And these just give a framework for the Hall switch to be positioned while we're tuning it, getting it set up to be placed where we want it, according to the efficiency we want to get out of it, or the power and so forth. So there's a specific place that works depending on the rotation in which you want to spin it. So I have one extra of these here that I can put on. Need to get some more wire, shrink tubes I should say. And you can leave these bare so that you can access coils individually. You don't have to put them in series. You can put them in parallel so long as they aren't reversed and cancel each other out. And then, like I do on my one kit here, I show usually, like you have 4 wires here so that you can do 2 different loads, which I usually run 2 light bulbs there when I demonstrate that. Usually you run 10 3-watt light bulbs on that at about 500 milliamps. Now I don't run them at full 3 watts usually. Okay, so now what we want to do is do the Hall switch, get it out of the way. Now the Hall switch, let's see if I can do this without the camera focusing on my face. Okay, so that's the top end of it. Now you can see in the diagram it will show that. And so we're going to face it literally. Oops. Like that, right underneath the south pole. Because these are south pole triggered. And we're going to face it, we're going to put it right in front of the generator coil, just off to the side. So right where the rods are, right in front of the rods, but off to the side. If you want to turn it the one way, if you want to turn it clockwise, you put it off to the left slightly. If you go too far, just past you'll see it will push more amps and it will be inefficient. If you push it too far away, it's not going to turn on at the right time. So I've already got these wires all ready to go. So what we have is a red, black. So the red wire goes first on the left side, black in the middle, and then white on the end, the right side. Don't put too much solder on this. Don't hold it for more than a few seconds, so you'll heat it up too much. And I've got 3 shrink tubes that I want to put on here to cover up the wires so they don't touch each other, and give place for this hot melt glue, which I've got to turn back on now. Well, actually I don't want to do that yet, because we have to have the circuit ready for that. So now make sure these are all up. So now these, you can still see the Hall in there. I used to put a bigger heat shrink tube over there, but then it didn't really matter. So I just used these 3. And now we'll put that aside. And we'll make the circuit now. So as I said, so this is the opto board to drive the FET from the Hall, and the wires are already bent, ready to solder. And if you look at the schematic, you will see where they actually go. The full illustration of the opto and the color of the wires and all that are right in there. So it's not like a real professional board, it's a proto board. But since I keep changing these kits, I'm not going to make up a circuit board only to change it again. There's only a few holes here anyway, it's not worth making a whole board for. So then you just cut the pieces off, the ends off. And And now, what I usually do is drill this I'm going to drill it onto the circuit board so that I don't drill through this really nice wood. so that I can attach these boards together is what I'm doing. Trying to figure out a good spot. This particular board already has a hole in it. So now you've got these two that you can use, these nut bolt plastic ones. But before we do that, we'll put the board together. So in this case, I've got two boards side by side. So this is going to be like the option. But normally you don't have this side of the board. You have this circuit board, it's already stuffed with the parts in it, so you don't have to worry which one is which resistor and what have you. They already have it in there, I just do it myself. And so really they just need to be soldered. But in this case, what I've done is I've cut that little trace to separate the two circuits, because they're going to be switched with different switching. The one is going to be switched with the Hall, which I'll show that in a minute, and the other one is going to be switched with the trigger coil. So we have to separate that. And I've also separated this. I'm going to be only running one coil with the trigger coil. So I did put the little diode in the hole. It's just going to come out so that that bus bar is only, the big fat bus bar on the bottom is only for the 3 coils with the Hall switching. But I'm going to right now solder everything together. And then we'll deal with it. Now, make sure your solder joints, you properly heat up the part before you touch the solder to the solder tip. You're supposed to actually touch the solder only to the part and let the solder roll. But that's not quite necessary. You can do a little bit of pre-tinning. It kind of gets the flow going, but you have to avoid making cold solder joints, which is where you didn't sufficiently heat up the part and the solder rolled off around the part and it didn't like have a clear flow. Like it will tend to bulge instead of just flow up the part. So the bigger the part, for example, these 3 amp diodes, they take probably a good 5 seconds with a 60-watt soldering iron like I have here to heat up before you can actually let the solder roll. So the parts can withstand, some time, not too long, but enough time to be able to solder. It's better to go a little bit longer than a little bit shorter, because if you have a cold solder joint, you're going nowhere. You're going to have a problem, or an intermittent problem where it works sometimes and not always. And believe me, I've had so many people send me back their machine they couldn't get working because essentially they made cold solder joints. And I had to find it. I went to one guy he flew me all the way over to his place, and he had an engineer actually build one of my big kits. And within 10 minutes I figured out what was wrong. Was had a big cold solder joint around the main negative terminal. I was like, well, there you go. One guy brought a 10 coiler to one of my first big meetings, and the guys had to totally redo it because all of the solder joints were cold. Alright, so alright, so I've done all the soldering. Now you hold it over a garbage pail and snip it. This gives you an opportunity to verify what you've missed. If you have enough pieces that you're trying to do all at once, it's easy to miss one. And see, sometimes one of these parts will be a little bit, have fallen out. So now, let's see what this. So now you can double check. Everything looks good. Sometimes you have one of the solder joints is a little less than desired. Now this board has extra holes in it so that you can do different things that we'll show in a moment. And also, we don't have the terminal strips on these because we're only using one board instead of 4. So I've got some extra holes here on the end of my whole 8 board, which we just cut up for these. And this gives me some places to put these big wires. Actually, so right now what we're going to do, before we connect these together, I'm going to add the various wires. So red wire from the hall is going to go to pin number 5, which already has the resistor across it. For those of you who are watching who don't have the kit, you don't need to know these things because I'm not showing these details in the schematic. Now there's another little red wire here that also connects to that same place, pin number 5. So just make sure you connect these up very well. Like I have a mistake there. It looked like it was soldered, but it was not connected. Alright, now right beside it is going to be pin number 4, and you're going to place the black wire across that. So you just go in front of the hole, right in front of it, fold it over. Now, you can pull the opto out before you solder if you're worried about damaging the opto and doing that. Then I just pre-tin these both ends of these wires. But I put the opto in there for you so that you know the direction, even though it's on the schematic. And sometimes I put them upside down myself, so you can verify the circle is pin number 1. So then we've got another white wire here that's going to go onto pin number 2. So right in the center, you're going to put that through, fold it over, and that's right below the other resistor that you've already soldered. Not quite good enough. You got to make sure the wires are flat. So now you've got 3 more wires to hook in. So now what we're going to do, this doesn't necessarily have to go in this spot, but there's on the top bus bar where the MOSFET is, or in this case the transistor on this side, there's a little tiny hole there right off to it, not the big hole. The little tiny hole I've made there so that you could put this wire in here. I thought I had when I made this board some years ago. Now the old boards that we used to sell 5 years ago or so, they were the exact opposite of this board. So if you have one of those, and when we actually made them, the guys did them backwards. Turned out better, but it was kind of confusing for the transition when customers had bought the old board. We made this board more compact with more holes and more functionality. So now we've got the boards essentially ready to go. So what I'm going to do is hook them together now. Through this one hole, which I have to make a little bit bigger. So I'm actually not going to use all those extra holes. I was, then I just changed my mind. So they don't have to be put together, but I like to have things nice and neat. And then this gives you kind of a lift off the ground so that the circuit board doesn't touch anything. So you can do whatever you want, whatever. Now we've got these extra wires coming through here. So the black wire, you're just going to either sneak under the board or over top of the board. In this case, I'm going to do it over top because there's a hole there. I'm going to run it to the trigger wire. I can't do that. Well, I cut it in the wrong spot. So that means I'm going to have to use a jumper, or no. I didn't cut it in the wrong spot. Good. Because like I said, I'm separating the two triggers, one from another, in this particular setup. So we're not going to run the other one at all until we get everything set up, the other wire. Now, the next step is to get our wires here. So we're going to put our black wire across the emitter on the top, big top bus bar. And this is going to be the primary negative terminal, the run battery negative terminal to the negative of the input battery. And then the charging positive is going to be on the other side, the big bus bar on the bottom where the big diode goes to, the 3 amp diode. So I just put it like that, and then the two other wires, the positive of the input battery and the negative of the charging battery, go together. So I've soldered them already, and now I have to decide where I'm going to place my switch. So I've got these little copper strips, and this is where I need my crazy glue. And I'm done with that. But while at the same time I'm using the crazy glue, I'm going to do two things at once. So this is going to happen fast. I'll bring the circuit there later on to show you. So I'm going to take this 10 microfarad 250 volt capacitor here. I'm going to dab it just with a little bit of crazy glue. If you put too much crazy glue on, it ends up taking forever to dry. So I've already cut these to size. Oops. Put them in the wrong spot. All right, now I'm going to take one of these switches. Now this is I only provide the switch for those who have bought it assembled anyway, so this doesn't really matter. But I'm making it so that you can switch between AC output, and I'll be using these wires here for that. And then I glue it so that the one, well, I guess it doesn't matter because you won't be seeing this. If you're assembling this, you won't have that particular part. So essentially, the two generator coil ends will come to the AC point of the bridge rectifier, the two center terminals. And the two outer ones will go to each side of the capacitor. So on the left side, I have it so that this is the positive. My right side will be to the negative. It's got the symbol on there to show you that. And then what we're going to do is run an SER, looks like a transistor. So I put the back plate in this direction, put a little crazy glue down, and I have it so that the legs, the bottom left leg, which is terminal number 1, the cathode, I connect to the negative of the capacitor and the bridge. And then we're going to be switching through that to the anode, which is the center terminal, will be the output. So we're done with that for now. We're going to trigger that with a diode only. But now I'm going to put these on my board somewhere here that I can put my switch. Again, not too much crazy glue, because, oops, if you put too much crazy glue on, it won't dry. Now, unfortunately, I flipped the crazy glue onto the copper, so I'll have to burn it off with the solder. So I pre-tin these, and then I've got another switch here, and I take all the nuts off of it and the washers. Now these are very sensitive, so I don't put hardly anything on these, just enough to get it started. If you see one of these terminals come out a little bit, the whole switch is gone. So you can't use the switch, and I only provide one. So I put two terminals on one side of the copper bus bar, and then the other bus bar. So I get them all flowing again before I put it down, and it's kind of a tricky thing. To do, and then hopefully I put it upright, and you could put it down on its side this way. That's probably better. I've seen people do that instead. That way, when I ship it, I should probably do that so that it doesn't break off somehow or another. Now, there's this one little red wire here that I haven't connected up to anything yet. So that is going to be going to the one end, the input end of the switch. It's got to be on the side where the battery wires are going, no, sorry, the other side. It's going to be on the coil side. I'll explain that in a minute. But first, we have a diode. And the diode is going to go in the direction to, the output is on the side going to the opto. So what I want to do is get this in here, and then I snip it, so I only need a little bit. I pre-tin it, which means put a little bit of solder on it. I get my heat shrink tube, which I've got to get more of, but I'm going to forget about that now. And then just solder it up. So that way, that diode, which I didn't used to have, and I found people putting their battery clips on backwards and blowing out a hall by reversing the terminals. So I figured, oh, let's put a diode in there so that people don't do that. And that definitely was a better improvement. So now what I want to do is connect up this particular wire up. See, it's hard to do this without a clamp. So you got to be careful again that you don't melt that switch down. So now what we have is it almost completed. We've got these 4 wires here that are going to the primary positive, like I said. So we want to get these ones all covered. First of all, we want to heat up all 4 of these wires. Again, these are the outer wires on the coils. So all the coils are parallel. So what I'm going to do, actually, got a little too much wire on there. Too much wire means sticks out too much. Alright, so now it's all connected except for the other end. So we've got these 3 wires, like I said. These 3 wires, usually I twist together. In this case, I'm not going to, because later on after this video, I'm going to do it the normal way, all 4 coils. Going in there, which means these wires I have to only solder at one point, so I can still stick the other wire through there later on. Now, that side's all ready to go. See, it's starting up by itself now. So now we can forget about all these other wires for a minute. And we can actually start running. Well, let's finish up this. So this one needs looks like I've got extra parts here. The SCR is subject to change. I have changed it from what's in the parts list, found a more affordable one. So if you see that difference, don't panic. It's just a different SCR. And since I already put all the MOSFET on the circuit board, you don't have to try and figure out which one's the MOSFET, which one's the circuit, or the SCR. So what I'm doing right now is connecting up all the terminals, all the legs. I'll show this in a minute. And you'll be able to see on the schematic the details of this. So we might as well get this all set and ready to go. And then we have our third wire here all ready to go. But we're going to actually have a fourth wire because I wanted to show a couple options here. One of them being a option of having a fourth battery charge, or so there's going to be a lot of options on this kit. I'll go through each one of them in time here. I don't want to get ahead of myself, be too confusing, because we want to just do the basics right now and then add, add the different options so that we don't say you have to do these options. Alright, so this is all ready to go. All it needs, oops, one more. All it needs is the wires. Well, what I'm going to do actually is hook up these also. That way we're all set. once this starts running, then we can just connect up the wires. I'm going to hook up, well, before I let me bring this up now and show. So you can see the connections, the SER, and how the diode triggers which one is which. Now what I'm going to do is, this particular terminal here is going to get the one end of the AC generator coil, and the center terminal I'm going to put the other end. But normally the switch is not there, and so it just goes directly to this, this terminal right here that I've cut. I'm switching between these two wires as the AC output and the DC output being pulsed. Now, this is the circuit board. We haven't worked with this side yet. That's going to be that's a transistor, 10 ohm resistor, and you can see how that one diode right here is not connected to that bus bar. So you can see what I've done with the switch. Oops. How I've made the wires on the switch. The little red wire coming to the diode. Oops. It's hard for me to... You can see that where the diode goes to the little red wire, and where it connects on the left side there. Or is that your right side? I forget now. So that's that. And then you can see where I cut the board there on the back, so that I separated that thinner trace, which is the trigger trace. And then you could see, oops, how I'm doing this right here. Like I said, we're going to put the hulls right in front of that generator coil, but off to, if we want to turn it clockwise, we want to turn it, go off to the right, and so forth for the other way. So this one is all ready to go. We're going to put the hull underneath that wire tie, and it holds it pretty tight. And then what we're going to do is turn on this glue gun again. Uh-oh. So we're going to have to wait till that warms up. So now we're going to bring the batteries over. So usually I'll write on the red for the assembled kits, I'll write on there which one's the charging battery connection. And now what we'll do is connect some batteries up here. Now these are, you can use both types of batteries here. I mean the same type of battery, you don't have to have the negatively charged battery. What we'll show in a minute running will show the negatively charged batteries for the optional output. So there's a battery sitting at 12.81 that was charged 1168 on this particular battery. And now let's that's the input, right? I just switched these batteries around. Yeah. Okay, so this will be the charging battery. And that is, you can always tell the charging battery clip is the one that goes to the diode, the red side. So you want to hook that one up first. Onto a good battery, please. You can rejuvenate batteries, but it's very risky to do with motors because if it doesn't have sufficient load, it will. I have the switch turned off. If it goes on when the switch is turned off, that means you shorted something inside, or the solder has jumped over your little terminals. So now, what I can do is hook up one of these wires already. So we'll take a longer wire of these two. It's hard to tell now. Okay, so those are those two. And I'm going to connect this to that little switch, that center terminal. Because it'll be harder to do this when it's running. Oops. All right, so that's that side. And we can separate this. This can go to a third battery. And we're going to use an ammeter to determine. So I'm going to just put this battery here. It's not connected yet to, we don't have the other wire connected yet because we got to determine which, well actually, yeah, we can already solder it because, well no we can't because we're not sure of what the voltage will be until we're ready. Alright, so we'll worry about that in a minute. Right now, we're going to focus on, get the ammeter ready. I'm going to put it at the 20 amp level because it is going to go up to 6 or 8 amps to start up. So again, I'm going to place this. I've done this so many times I can do it with my eyes closed almost. But there's always a slight difference between each one of them. So now we can look at the voltages at the same time. Does it charge batteries? Is that for the first time ever in the world? I'm going to show something that no one's ever seen before. No, we've seen this before. It's remarkable. It really is. And it's amazing that hardly anybody knows about this. Well, somebody wrote on YouTube, the other day, everybody would know about it because of social media, because social media determines the truth. what's trendy is true. Remember that. And what's new is true, what's old is mold. Alright, so we're at 1273 on this particular battery. Alright, so now let's go up and turn it on, I should say. And make sure our wires are connected. So you can see, now it's going to take probably a couple of hours before that lube really penetrates in to the bearing. And so you'll hear this kind of sound, like, because there is liquid, excess of liquid there. So you can see it's charging up, 13. And this particular system, it's more characteristic of its state of charge than with the trigger coil, which tends to boost the voltage up a lot higher. So we're drawing about 0.9 amps right now, 900 milliamps, and we can move this around. So I'm still waiting for it to get up to speed. So typically it can get up there to thousands of RPM on this thing. And either between 500 milliamps to, so you can hear it go through resonance, the aluminum rotor resonating, and you can hear that happen a couple times on this at 12 volts. So I'm pushing it a little too far and the amps go up. And I'm just deciding where I want to keep it. Now this is only 3 coils, so I'm forgetting that. The 4th coil is not connected yet because it's going to be for the trigger coil. So usually, I should bring it down a little bit because so now what I do is I turn it off for a minute. And then I put my hot melt glue on it, just kind of like on all 4 corners on either side of the wire tie. And then I can turn it back on so that it will dry faster, and then I can reposition it if I need to. So now in the meantime, we can look at the AC voltages to determine which wire goes where. Because I had that one coil upside down. And maybe I'll discover something with that. No. Alright, so I'm going to connect up, in this case actually, I'm going to connect up to this wire. And then what I want to do so we're at 20 volts over there, 31 volts there. Now we've got to find which wires so if we connect these wires up, we'll be able to determine So there's 43 volts. Now if I change this, it gives us back 20 volts. So this wire has to be the end wire, which is what we were going to do there in the first place. And then these two wires come together. So we're at 43 volts with only 3 motor coils. And let's unplug this wire, this thing here. And then we'll have to strip that wire again. Alright, so now what we have to do is cut this other wire down to size so that it lines right up. And then we'll solder it together. Oops. See, I got this too high and I just ripped off a whole bunch of wire. Alright, so we've settled down to 760 milliamps. So I kind of twist these wires before I solder them. And I usually put a heat shrink tube over it. Now, so far we don't have anything on the, we're not charging up this yet until we flip the switch. So we're at, oh, we gotta go on to DC. So 1161, and what we're gonna do, flip the switch, and you can see it's already at 1178, 79. You can hear it's slightly slowed down the RPM. So now, let's go back, and we're charging up that battery slowly, but decently. For very little, like I just turned it off right now, and there's hardly any difference in RPM. So now let's look at this. You can hear it speed up. I'm shorting it out right now. It's speeding up quite a bit. It's a significant difference. my amp draw goes down slightly. So now it's going back down. And when I short it out, the amp draw goes down. When I unshort it, now when I do this, my amp draw goes down too on this load. Now it's down to 720 milliamps instead of 740. So depending on the loads that you're running, if we get that ideal load, which I have some bulbs that burn very bright, that act like a dead short, then this can speed up and draw less amps. Now that's not a major aspect of this kit, but it is definitely one thing that I wanted to show everybody. It's kind of a historical thing. The first motor sold like this that really did this. Not that others didn't do this years ago, I've never seen them for sale. I showed you the patents from the 70s, and yes, before Bedini's day, they had patents that you loaded down the motor and it sped up, it drew less amps. Alright, so we're all good here. This is the whole kit. That's the end of the demonstration of how to build the kit. Now what we're going to do is move on to the next phase. And we're not going to do this running because, so you can see the charging battery is going to go back down. And we're going to go back over to the well, we'll just put this over here. So this will go back up, 1258. Now I don't have any kind of recovery on this like we do in the other videos. But you can see this battery has charged to some degree from what it was.